The discovery of antimicrobial agents has been a revolutionary phenomenon in the field of science and medicine. Since its first usage, it has greatly reduced the number of illness and death from infectious diseases. However, antibiotics have been used so widely and for so long that it has resulted in antimicrobial resistant bacteria to transpire, and the overuse of antibiotics now threatens to impede the medical advances made over the past 70 years. And an important contributor to the overall phenomenon of resistance to antibiotics is the extensive use of antimicrobial agents in food animal production. For about as long as antimicrobials have been used in human and veterinary medicine, antimicrobials have also been applied in agriculture, aquaculture, and animal husbandry to prevent, control, and treat infections. However, typically in the case of infectious diseases, the whole flock is treated to prevent the spread of illness, even if only a few animals within a group exhibit clinical symptoms. In addition to the extensive use of antibiotics for disease prevention and treatment, antimicrobial agents have been administered to food animals for the purpose of growth promotion. It was noticed that small subtherapeutic doses of penicillin and tetracycline could enhance weight gain. Because bacteria are so adaptive, it's not hard to believe that bacteria would adapt and mutate to become resilient after antibiotics have first been introduced. An example is Salmonella species, one of the most important foodborne pathogens. It has exhibited multi-drug resistance to various agents, including tetracycline, streptomycin, and some of the beta-lactam antibiotics such as penicillin and cephalosporins. Most of these antimicrobials can be found in concoctions fed to cattle. In the U.S., non-therapeutic use of antimicrobial agents in agriculture account for nearly 80% of drug production, which far exceeds the amount of all antibiotics prescribed for human therapeutic use. The overuse and misuse of antibiotics can and have resulted in antimicrobial resistant genes to be passed horizontally within and between bacterial species. But bacteria aren't the only organisms at risk to exposure from these new strains of pathogens. The presence of drug-resistant pathogens in food animals and their waste means people working in farm environments are exposed as well. That includes farmers, veterinarians, ranchers, and the other approximately 1.2 million workers that work in the U.S. animal industry. The consequences of such prominent presence of antibiotic-resistant bacteria within our population includes delay or failure of treatment and limited choice of antimicrobials. Furthermore, the increased use of the effective antibiotic can also increase the possibility of the appearance of new resistant strains. So now here to provide his insight on this topic is my husband Boone. Why do you think so many antibiotic-resistant bacteria have come out of the U.S. agricultural industry?
When discussing bacteria, the important thing to note is that bacteria split. We'll talk about the bacteria that commonly causes staph infection. It splits about once every 30 minutes. That doesn't sound like a lot because it grows exponentially. After just 10 hours, one bacteria can turn into a colony of over a million. Assuming the bacteria's genome has about 2.8 million nucleotide base pairs, and assuming a mutation will occur about 1 out of every 10 to the 10th of those base pairs every time the bacteria split, that means after just 30 hours, every single base pair will have mutated 30 times in some bacteria in that population. Now that's a lot of mutations. Presumably, some of those mutations won't really do anything useful for the bacteria, and some of them might actually hurt the bacteria. But there will be a few that add to the bacteria's resistance to antibiotics. Now, if you go through an entire session of antibiotics, it will kill hopefully all the bacteria. But if you don't use the antibiotics correctly, that means that you'll kill all the weakest bacteria and leave only those with the mutations that help them resist the antibiotics. In simple terms, what this results in is bacteria that are extra resistant to antibiotics, and we call these bacteria antibiotic resistant bacteria.
So then, why can't we just stop using antibiotic in livestock?
Well, the reason is both political, there is the farm lobby, but also economic. The second we quit using antibiotics on livestock, the cow's size will go down, as already mentioned. And also, we'll probably have to shift the cows off a pure grain diet and maybe, put some grass in there. And so we have no idea what that will do to the price of beef, eggs, milk, and anything else you eat that comes from an animal. And those likely hardest hit from this will be those who are in the lowest socioeconomic status in the country.
So, if we can't stop using it, then we certainly have an urgent need to provide alternatives to antibiotics, whether that's in the form of an immunization program by vaccination, or perhaps the improvement of the gut bacterial flora by the use of probiotics, prebiotics, and symbiotics. Because the annual cost of the increased healthcare economic burden was estimated to be between $4 and $5 billion, and that doesn't even factor in the loss of workdays and productivity. And even with the call for limiting antimicrobial use in livestock by the US FDA, the consumption of antibiotics for animal use follows an ascending trend still. After all, at the end of the day, this issue doesn't just take place on the farm. Everyone who has had used antibiotics has a share in the emergence of the resistance, and we all must collectively help to stop this global threat. Thank you for watching and listening to my final presentation in microbiology on the topic of antimicrobial resistant bacteria in agriculture.